today, go to page 131 of your journal and read over the properties of radicals. We have the product property and the quotient property. It basically tells you that you can combine certain things in the same radical by multiplying or dividing, and you can also break them apart. Then I want you to go to your notes packet, page 6, and start with example 6. We want to simplify these expressions. We're going to use all of the products that we learned from the previous video and the products that we just talked about now. Here we have the cube root of 64, y to the 6th. We want to write things in terms of the 3, the cube root. So I have to think, what number, how can I write 64 to the 3rd power? Or is that possible? And we'd find out it is possible. We can write 4 to the 3rd, and then y to the 6th, we can split up and write that as y squared to the 3rd power, because 3 times 2 is 6. Then we can break this apart and say the cube root of 4 to the 3rd times the cube root of y squared to the 3rd. And then we know from there we can cancel out these cube roots. I don't know what's happening there. And we can get the cube root of 4 to the 3rd is just 4 times the cube root of y squared is just y squared. And that's our final answer. Now we want to do part B. I'm going to split this up and write this as the 4th root of x to the 4th over the 4th root of y to the 8th. But we can't really break up y to the 8th just yet. So what we can do is simplify the top, the 4th root of x to the 4th. That's going to be the absolute value of x. And then in the bottom, we do know that y squared to the 4th power is going to be y to the 8th. So now the 4th roots will cancel, and we like that because we don't like radicals in the bottom. And our answer will be absolute value of x over y squared. The reason for the absolute value is because x to the 4th power, if it's positive or negative, it will become positive no matter what. So when we cancel those roots out, if it's even, you have to add those absolute values. Now take a look at example 7. Part A, we want to break it down into fifth roots. So I can't do anything with the 4th, but a to the 8th, I can make that a to the 5th times a to the 3rd. B to the 14th, I can make that b to the 10th times b to the 4th. And then I have c to the 5th. So now I can focus on all of my exponents that go into 5. So I have the 5th root of a to the 5th, b to the 10th, c to the 5th, times the 5th root of 4, a to the 3rd, b to the 4th. And I know I can simplify this because this first part, because the 5th root of a to the 5th is just a, the 5th root of b to the 10th is b squared, and then we have c, all times this quantity here. So 4, a to the 3rd, b to the 4th. And there's our... So part B, we want to multiply the top and the bottom by the cube root of y so that we can simplify and get rid of this cube root in the denominator. So cube root of y over cube root of y. So in the top we'll have x to the cube times cube root of y divided by, so the cube root of y to the 8th times y to the 1st, which is y to the 9th. So then when I simplify that, I get x times the cube root of y divided by just y to the third, because 9 divided by 3 is 3. And there's our answer. For part C, we want to start off by dividing those numbers. 14 divided by 2. So what's that? Good, that's going to be 7. And then we have x to the first over x to the 3/4. So we do x to the 1 minus 3/4. Then we have y to the 1/3. Keep that the same. And then we have z to the -6th in the bottom. If that's in the bottom and it's negative, we could just move it up top and make it positive. So z to the 6th. And then when we simplify all of that, we get 7 x to the 1/4, y to the 1/3, and z to the 6th. So that's your final answer for part C. Now I want you to scroll down to, or go to the next page to example 8, and we're going to combine like terms here. So I see square root of y and square root of y, so I can just say that's 5 plus 6 times the square root of y, and that would just be 11 square root y. So 11 root y is your answer. For part B, it's a little more complicated. I see 2z to the 5th and 54z squared inside the cube roots. I want to try to get those to be the same. So I'm going to keep the 12, and then I'm going to say this is the cube root of z to the 3rd times z squared. But that 2 is still there. I should have written that first, but that 2 is still there. And then minus z times the cube root of 27 times 2, because that's 54, times z squared. So notice here, the 27 and the z to the 3rd, we're going to simplify. So we're going to get 12 cube root of z to the 3rd is just z. And then we'll have the cube root of 2z squared minus, cube root of 27 is 3? Yeah, 3z times the cube root of 2z squared. Now we can see we have the cube root of 2z squared for both. So just take 12z minus 3z, which is 9z, and then multiply that by the cube root of 2z squared, and that is our final answer. We'll do the monitoring progress in class tomorrow, and then we'll start the next section.